When British troops assaulted the Normandy coastline in the summer of 1944, they brandished a firearm that had been in service for nearly half a century. The short-magazine Lee-Enfield, conceived in 1895 and officially adopted a dozen years later, remained the standard-issue weapon for Commonwealth forces. Meanwhile, their German counterparts employed the Carabiner 98K, a refined variant of the legendary Mauser action that had been perfected over the course of many years. On paper, this should have been a mismatch. The German rifle boasted superior accuracy at distance, more modern construction materials, and what many ballistics specialists deemed the pinnacle of bolt-action design. Yet, British soldiers who captured German weapons on the battlefield frequently discarded them in favor of retaining their familiar Lee-Enfields. The tale of the Lee-Enfield rifle's origins can be traced back to the 1880s, when the British military recognized the need for a repeating firearm utilizing smokeless propellant. James Paris Lee, a Scottish-Canadian inventor, had pioneered a revolutionary detachable box magazine system. When this innovation was paired with the rifling expertise of the Royal Small Arms Factory in Enfield, the result was the magazine-fed Lee-Enfield. First deployed during the Second Boer War, the design underwent several refinements, culminating in the iconic short magazine Lee-Enfield Mark III by 1907. This resilient rifle would go on to serve through 2 world wars and countless colonial conflicts. The enduring appeal of the Lee-Enfield stemmed not from sentimentality or stubbornness, but from the pragmatic battlefield lessons learned through hard experience. The standard military mindset of the era prioritized long-range precision. European forces were fixated on hitting targets from distances of 800, 1,000, or even 1,500 yards. The Germans, in particular, took great pride in their marksmanship, and their Mauser rifles embodied this philosophy with longer barrels and tighter manufacturing tolerances. In contrast, the British adopted a different strategy with the SMLE. They shortened the barrel to just 25.2 inches, making the rifle more maneuverable in trenches and vehicles. They were willing to sacrifice some long-range accuracy because their combat analyses revealed that most infantry clashes occurred within 300 yards. The key to the SMLE's enduring success for nearly a century wasn't any single revolutionary feature, but rather a combination of practical design choices that prioritized what truly mattered in combat. These pragmatic decisions, rather than a single groundbreaking innovation, were the driving force behind the rifle's longevity and effectiveness. The conventional wisdom among European military strategists was challenged by this unorthodox approach, yet its prescience became evident as the realities of trench warfare emerged after 1914. The distinctive rear-locking bolt design of the rifle raised eyebrows among firearms experts, as it diverged from the more common front-locking system used in weapons like the Mauser, where the pressure of firing was borne by lugs near the chamber. In contrast, the Lee-Enfield's bolt lugs were situated at the rear, which some argued would compromise its strength and accuracy. While these critics were correct in their assessment of the rifle's performance on the target range, the battlefield proved to be a very different environment, where the Lee-Enfield's design offered advantages that outweighed the slight reduction in precision. The venerable SMLE rifle, despite its age, remained a formidable weapon in the British arsenal. Its rear locking system, while requiring a slightly longer bolt travel, actually enhanced its cycling speed, and the action proved remarkably resilient to dirt and debris. As the world hurtled towards another global conflict in 1939, the SMLE was theoretically outmoded. Yet, rather than phasing it out, production ramped up significantly, with factories across Britain, India, and Australia churning out millions more. British commanders recognized that what appeared impressive on paper didn't always translate to real-world superiority. They upheld a demanding training standard that seemed daunting to new recruits. Every soldier was expected to fire 15 aimed rounds per minute, a testament to the SMLE's reliability and the soldiers' marksmanship. The British Expeditionary Force in the opening months of World War I owed much of its survival to a remarkable tactical doctrine known as the Mad Minute. Skilled riflemen could unleash a blistering 30 to 38 rounds from their Lee-Enfield bolt-action rifles in just 60 seconds, a feat that stunned the advancing German forces at the Battle of Mons on August 23, 1914. Facing a numerically superior German army of around 160,000 men, the British contingent of roughly 70,000 soldiers met the onslaught with a devastating hail of rifle fire that the German commanders mistakenly attributed to hidden machine guns. In reality, it was the sheer marksmanship and rate of fire of the British infantrymen that turned the tide of the initial engagement, defying the German expectation of a swift and easy victory against what they had perceived as an outdated and inferior force. The short-magazine Lee-Enfield, SMLE, rifle was engineered for rapid fire efficiency. Its bolt mechanism featured a 60-degree angle rather than the typical 90-degree design, reducing the throw distance and enabling quicker successive shots. This natural hand positioning eliminated excessive wrist rotation. Additionally, the rear locking bolt required the shooter to actuate the firing pin upon closing the bolt, a more intuitive motion during rapid engagement. The smooth ejection of spent casings without mainspring resistance further streamlined the reloading process, allowing the marksman to concentrate solely on chambering the next round. Through rigorous training, this innovative firearm system empowered individual soldiers to become formidable combatants. The British Army's musket training regimen was renowned for its rigor and intensity, surpassing even the most demanding programs of the era. Recruits underwent weeks of intensive drills at the firing range before ever engaging in other combat exercises. They mastered the art of shooting from a variety of stances, including standing, kneeling, sitting, and prone positions. Rapid magazine changes were a critical skill, with soldiers trained to swap out a fresh 10-round magazine in under 3 seconds. Estimating range and adjusting sights accordingly was another key component of their training. While the SMLE's ladder sight system may have appeared antiquated compared to German designs, it actually allowed for quicker adjustments under the stress of combat. With a simple flip of a lever and a slide of the sight to the required range marking, soldiers could lock it in place without the need for fine-tuning or overthinking, prioritizing practical speed over complex mechanisms. The grueling marksmanship trials demanded that aspiring soldiers strike a 12-inch target 15 times in just 60 seconds from 300 yards away. This daunting task necessitated the rapid reloading of a fresh 5-round magazine mid-drill, all while maintaining pinpoint accuracy. Those who could achieve 20 hits were awarded the coveted marksman distinction. 607 legendary instructor Sergeant Snowoxall was said to have astonished onlookers by scoring an astounding 38 hits in a single minute during a 1914 demonstration, though he required the assistance of a loader to feed him pre-loaded magazines. 614 The true purpose, however, was not to set records, but to ingrain such instinctive muscle memory that soldiers could deliver rapid, accurate fire even amidst the stress and chaos of battle. 622 At the Battle of Mons, German troops advancing in formation were cut down at ranges where they lacked the ability to effectively return fire. The German forces were stunned by the relentless barrage of gunfire they encountered, which they firmly believed originated from numerous machine gun positions. In reality, this formidable volume of fire was produced by just 8 to 10 British riflemen. A captured German lieutenant later admitted to having meticulously counted the rate of fire, and concluded that his unit was facing at least 20 machine guns. He simply could not fathom that bolt-action rifles were capable of generating such overwhelming firepower. At the Battle of Mons, the British had only 4 machine guns per battalion, with the majority of their firepower coming from their rifles, training, and the rapid-fire capabilities of the SMLE rifle. The transition to trench warfare proved to be a daunting challenge for weapon designers, as features that appeared elegant on the drawing board often proved impractical in the harsh realities of the battlefield. The harsh realities of the Western Front exposed the limitations of a factory testing environment. Rifles endured prolonged exposure to the elements, with the corrosive Flanders mud infiltrating every crevice. Soldiers struggled to maintain their weapons as prescribed in peacetime manuals, lacking the amenities of a heated armory or adequate cleaning supplies. Yet, the Lee-Enfield rifle proved resilient, its deliberate manufacturing tolerances allowing it to thrive where more advanced designs faltered. The British Lee-Enfield rifle exhibited a more forgiving design compared to the meticulous German Mauser 98K. While the German weapon prioritized precision, the Lee-Enfield allowed for greater play between moving parts. This proved advantageous in the harsh battlefield conditions, as the extra clearance enabled the rifle to function even when caked in mud or ice. In contrast, the Mauser's tighter tolerances and front-locking lugs near the chamber were prone to binding and jamming when debris accumulated. As a result, German soldiers often struggled to clear their weapons, while their British counterparts maintained a steady rate of fire. The Mauser's ingenious bolt design offered a distinct survival edge. By compressing the mainspring only when closing the bolt, less force was needed to operate the action. This proved invaluable when the mechanism became fouled or iced over, as British troops in the harsh winter of 1917 discovered. While German prisoners' weapons had frozen solid, the British rifles continued to function reliably, despite similar maintenance levels. The Mauser's superior engineering made it more resilient to the extreme cold, a critical advantage in the field. The SMLE's magazine design incorporated a cutoff mechanism, allowing it to be used as a single-shot rifle while preserving the magazine's contents. Crucially, the magazine well was engineered with drainage, enabling water ingress to flow out rather than pooling around the cartridges, preventing corrosion or feeding issues. In contrast, the Mauser's internal magazine, loaded via stripper clips, lacked such drainage. Any water entering the action would remain, mixing with gun oil and powder residue to form a corrosive paste. British armorers, salvaging German weapons after major offensives, observed that captured Mausers often exhibited rust and corrosion within the magazine, even when the external metalwork appeared unaffected. The rifle's wooden components. The rifle's wooden stock, typically crafted from the relatively soft Indian walnut, demonstrated an unexpected resilience. 10 o'clock This material absorbed impacts without cracking, allowing the weapon to withstand the rigors of trench warfare. 10:07 Soldiers frequently used their rifles as makeshift tools, driving stakes, opening crates, and breaking ice, stresses that would have shattered the harder beechwood stocks common in the Mauser design. 10:13 Damage to the stock was not merely cosmetic, as it could compromise accuracy and even render the rifle unsafe to fire. 10:20 Ordnance reports from the Somme offensive revealed that the Lee-Enfield suffered far fewer catastrophic stock failures compared to captured German Mauser rifles subjected to similar field conditions. 10:26 This material resilience contributed to the Lee-Enfield's reliability in ways that defied conventional expectations. 10:32 The iconic Mauser 98 bolt-action rifle has long been hailed as one of the most successful and influential designs in the annals of firearms history. Conceived by the renowned German engineer Paul Mauser in 1898, this seminal weapon served as the template that countless nations would go on to emulate or adapt for their own military needs. Its ingenious controlled feed extractor mechanism, which firmly gripped the cartridge rim as it exited the magazine, ensured a smooth and reliable chambering process. Moreover, the dual front locking lugs positioned directly at the chamber provided maximum support precisely where firing pressures were at their peak. The rifle's three-position safety further allowed the bolt to be opened with the safety engaged, facilitating the safe unloading of the weapon. On paper and in the field, the Mauser 98 represented the pinnacle of bolt-action engineering. This was a fitting reflection of the German military's emphasis on marksmanship, as their soldiers were extensively trained to wield this formidable firearm with precision and skill. The German Key 98K rifle, wielded by a skilled marksman, could reliably outperform the British SMLE at 600-yard targets. However, the true test of a weapon's worth extends beyond the confines of the shooting range. The Mauser's precision was both its strength and its limitation. The tight tolerances that ensured accuracy also made the action less forgiving. While the controlled feed system offered theoretical advantages in reliability, it required a more complex and lengthier bolt manipulation. Operators had to lift the bolt handle a full 90 degrees, pull it straight back, push the new round forward, and then rotate the handle back down, each step requiring deliberate execution. The German military's approach to marksmanship emphasized precision and restraint. Their training manuals underscored the importance of controlled breathing, smooth trigger manipulation, and proper sight alignment. Soldiers were expected to make every shot count, especially at extended ranges where the Mauser's superior accuracy shone. This philosophy aligned with the realities of late 19th century warfare, where engagements occurred at longer distances and ammunition supply was a persistent challenge. However, the nature of infantry combat had transformed by 1914 and again by 1939. Rushing the process could lead to feeding failures or double feeds. Under the stress of needing to engage targets quickly, with cold or shaky hands, that technical complexity became a hindrance. In contrast, the German approach prioritized deliberate, aimed fire. A German soldier was trained to make each shot count, particularly at longer ranges where the Mauser's precision gave it an advantage. This doctrinal emphasis made sense in the context of earlier conflicts, where engagements happened at greater distances and ammunition conservation was a constant concern. But the realities of infantry combat had evolved significantly by the outbreak of World War I, and even more so by the start of World War II. The advent of automatic weapons ushered in an era of sustained firepower, while artillery became the dominant force on the battlefield. The infantryman's role evolved, emphasizing rapid response at closer ranges, where the advantages of the SMLE rifle became particularly evident. The practical implications were evident in the rate of fire. A well-trained German soldier could discharge approximately 10 to 12 aimed rounds per minute with the KW-8K, a respectable performance compared to most other armies equipped with similar rifles. However, this rate was only half the standard for the SMLE. In a firefight lasting 2 minutes, a British soldier could unleash 30 rounds downrange, while their German counterpart managed 24 at best. Those extra 6 rounds represented potential casualties inflicted or suppressive fire that kept the enemy's heads down. Multiplying this advantage across an engagement could have significant tactical implications. The German infantry's reliance on their formidable MG-34 and MG-42 machine guns became a decisive factor, as they struggled to match the sheer volume of fire generated by British sections armed solely with rifles. The Mauser's longer barrel, measuring 23.6 inches compared to the SMLE's 25.2 inches, granted it superior muzzle velocity and a flatter trajectory at longer ranges. German snipers favored the Cayenne IE-8 caliber for this very reason. However, for the average infantryman, this enhanced accuracy potential often went underutilized. Extensive combat studies from both world wars consistently demonstrated that most soldiers were unable to effectively leverage the maximum accurate range of their weapons under the stress and duress of the battlefield, as the noise, confusion, fear, and physical exhaustion degraded their marksmanship abilities. The renowned SMLE rifle proved more than adequate for the typical combat ranges, with its rapid operation outweighing any inherent precision constraints. While most soldiers struggled to maximize the weapon's accuracy, the magazine capacity proved a critical factor in the heat of battle. The British Lee-Enfield boasted a 10-round detachable magazine, compared to the 5-round internal magazine of the German Mauser K98K, granting a decisive 2-to-1 advantage. When a British infantry section unleashed fire, they could sustain it for twice as long before needing to reload. And when that moment arrived, the Lee-Enfield's magazine swap took a mere 3 seconds. With a practiced hand, the German soldier swiftly reloaded his Mauser rifle. First, he opened the bolt, then positioned a 5-round stripper clip in the guide. Applying thumb pressure, he pushed the cartridges down until they fed into the magazine. Next, he extracted the empty clip and chambered the first round. Even a well-trained soldier required 6 to 8 seconds to complete this process, assuming the clip fed smoothly without any jams. This capacity difference multiplied across an engagement, significantly impacting the firepower of small combat units. A standard British infantry section consisted of 10 men. During a sustained firefight with all rifles firing, that section could deliver 100 rounds before anyone needed to pause for reloading. The British section's firepower advantage was undeniable. A comparable German squad of 10 men could only deliver around 50 rounds in a 2-minute engagement, while the British managed roughly 300 rounds. This wasn't just about ammunition expenditure, it was about maintaining continuous fire. As German soldiers paused to reload, their British counterparts kept up the pressure, suppressing the enemy and creating opportunities for flanking or advancing. The detachable magazine system gave the British soldiers a tactical edge, allowing them to carry loaded magazines and swap them out quickly for uninterrupted fire. The British military's standard battle formation incorporated 2 pouches, each containing 5 10-round magazines, providing a readily available supply of 50 rounds. Additionally, soldiers carried another 50 loose rounds in bandoliers, allowing them to quickly refill their magazines during lulls in combat. This setup enabled soldiers to fire 50 aimed shots in under 4 minutes without the need to fumble with individual cartridges. In contrast, German soldiers carried their ammunition in pouches designed for stripper clips, which, while efficient for their weapons design, required manipulating small metal clips under the stress of battle. Dropping a clip in the mud or grass could make those 5 rounds challenging to recover and use. The magazine cutoff feature added another practical element, allowing soldiers to disengage the cutoff and maintain a continuous supply of ammunition. The Lee-Enfield's versatility shone through its ability to transform from a single-shot firearm to a fully loaded magazine-fed rifle. This adaptability proved invaluable in scenarios where ammunition conservation was paramount, yet the need for rapid fire could suddenly arise. With the SMLE, you could selectively engage targets, feeding individual rounds through the action, then instantly revert to a fully loaded magazine if the situation escalated. In contrast, the Mauser lacked this seamless transition, forcing the user to either expend the entire magazine or load single rounds. The SMLE's magazine well, with its generous size and beveled design, further simplified reloading, even in challenging conditions like darkness or when fatigued, allowing the user to guide the magazine into place by feel. The magazine release was situated precisely where your trigger finger instinctively fell when transitioning your grip for reloading. A single press, and the empty magazine swiftly detached. Insert the fresh one, push until you heard the reassuring click, and you were back in the fight. The Mauser's internal magazine meant no dropping or inserting magazines, which seemed advantageous until you realized it also precluded the option of a rapid reload. Once your 5 rounds were expended, you had to feed the rifle slowly, cartridge by cartridge or clip by clip. German soldiers admired the British magazine system even as they took pride in their rifles' other qualities. In October, Private Harold Bolton of the Royal Warwickshire Regiment wrote home describing his experiences. The aftermath of the initial Ypres clash in 1914 witnessed a peculiar occurrence. Borden's unit had successfully overrun a German position, uncovering several abandoned Mauser rifles in excellent condition. The soldiers examined these firearms with professional interest, as German propaganda had touted their superiority over the British-issued weaponry. Borden's seasoned sergeant, a career soldier with over a decade of experience, meticulously inspected the Mauser's action and sights, then handed it back with a succinct remark. "Fine for a Sunday shoot, but I'll stick with me Lee-Enfield for killing Germans." The captured rifles were subsequently turned over to headquarters, while every man in Borden's section retained their trusted SMLE. This pattern repeated itself across both fronts during the engagement. After major battles, British and Commonwealth soldiers frequently encountered German firearms. Some kept these as mementos, while others utilized the captured ammunition when their own supplies dwindled. However, when given a choice, the troops overwhelmingly preferred their trusty Lee-Enfield rifles. Corporal Jack Thomas, who fought with the 8th Army in North Africa, maintained a wartime diary that endured. In a January 1943 entry following the Mareth Line engagement, he recounted his platoon ransacking a German supply depot. They seized ammunition, rations, and even a few MP-40 submachine guns, yet the captured Kar 98K rifles were left untouched. As Thomas noted, "The lads won't trade their rifles. Jerry's looks smart, but ours. The Royal Armoured Corps veteran, Lieutenant William Douglas Home, documented his wartime experiences in letters that were later made public. After interrogating German prisoners in Normandy during July 1944, he noted their respect for the British forces' marksmanship and rapid rate of fire. One German sergeant, through a translator, expressed his squad's belief that they had faced automatic weapons during an engagement near Caen. When Douglas Home clarified that they were actually bolt-action rifles, the sergeant initially refused to believe him, insisting that no such weapon could maintain that volume of incoming fire. Douglas Home then produced an SMLE rifle and demonstrated its impressive rate of fire. The sergeant's countenance, as described by Douglas Home, conveyed a blend of reverence and profound exasperation at being outmatched by what he had deemed obsolete equipment. This sentiment was not exclusive to the British. Indian Army troops, who comprised a substantial portion of Commonwealth forces, were equally devoted to the rifle they referred to as the .303, named after its caliber. Sepo Singh of the 4th Indian Division wrote to his family in Punjabi, recounting the East African campaign against Italian forces in 1941. His unit seized Italian Carcano rifles and German Mausers being utilized by colonial troops. Singh recounted attempting a Mauser and finding it too sluggish for combat, suitable only for precise shooting. The Indian Army had long favored the Lee-Enfield .303 rifle had been the trusted sidearm of Indian soldiers since 1905, earning acclaim for its remarkable reliability and rapid-fire capabilities across the war's diverse theaters, from the scorching deserts of the northwest frontier to the humid jungles of Burma. Troops attested that the iconic SMLE, short magazine Lee-Enfield, continued to function flawlessly even when other firearms faltered under the strain of the war's harshest environmental conditions. Australian soldiers, known for their pragmatic approach to equipment, readily adopted any tools that proved more effective, disregarding official protocols. Sergeant Bill Griffiths, a veteran of the 9th Australian Division who fought at Tobruk and El Alamein, meticulously documented the constant evaluation of captured German gear by his comrades. The Australians enthusiastically embraced the superior German stick grenades, readily incorporating them into their arsenal. The Australian soldiers in North Africa and the Pacific displayed a pragmatic approach to their weapons. They scavenged German optics and machine guns, but Griffith noted that he never saw an Australian voluntarily replace their trusty Lee-Enfield rifles. The attitude was simple: the bloody thing works. Shoots straight enough and shoots fast. Why would you change? The harsh conditions of the North African desert put weapons to the ultimate test, as sand infiltrated every mechanism, and the extreme temperature fluctuations from freezing nights to scorching 120-degree days caused metal parts to expand and contract. The combination of coastal moisture and abrasive sand created a paste that could rapidly wear down even the most durable equipment. The British military forces engaged in a protracted campaign across North Africa from 1940 to 1943, battling in the harsh desert environments of Libya, Egypt, and Tunisia. During this time, they found the venerable SMLE rifle to be far superior to most other small arms in handling the challenging conditions. While German troops respected the precision of the Mauser, their field manuals detailed extensive maintenance procedures required to keep the K98K functioning in the desert. In contrast, British manuals simply advised soldiers to shake out the sand and continue firing. The very design features that had drawn criticism from engineers, the SMLE's loose tolerances, proved to be a blessing in the desert. Sand that would have jammed the tighter actions of the Mauser simply fell through the Enfield's more generous clearances. Australian and New Zealand troops fighting at Tobruk endured sandstorms that reduced visibility to arm's length, yet the SMLE's reliability ensured they could keep up the fight. The Italian Corono rifles wielded by adversarial troops often succumbed to complete seizure following sandstorms, necessitating thorough disassembly. Even the renowned Mauser firearm required extensive cleaning before reliable operation could resume. Armorer reports from the Tobruk siege noted that Lee-Enfield rifles returned for repair were caked with sand within the action, yet most still functioned adequately for combat. One documented instance from August 1941 described a rifle that had fired over 200 rounds across a 3-day skirmish without cleaning, and remained operational upon final inspection. In contrast, the Burma and Pacific theaters presented the opposite challenge: torrential monsoon rains, perpetually damp jungle humidity, and mud that impeded. The British 14th Army, engaged in combat operations in Burma from 1942 to 1945, faced environmental challenges that contrasted sharply with the conditions in Flanders. The tropical climate of the region led to rapid rusting of metal components and significant swelling of wooden rifle stocks due to moisture absorption. While the Japanese Arisaka rifles were well-designed weapons, the humidity affected their chrome-lined bores, causing feeding issues. In contrast, the unlined bore of the SMLE rifle required more frequent cleaning but proved less susceptible to pitting and corrosion when the chrome plating failed. The walnut stocks of the British rifles were better able to withstand the moisture without the dramatic swelling observed in the denser woods used in Japanese and some German rifles. Soldiers of the 14th Army operating in the Arakan and along the Chindwin River often went for weeks without access to proper maintenance facilities, further exacerbating the challenges posed by the harsh environmental conditions. The Border Regiment's Sergeant Charles Carfree recounted the condition of his rifle after 3 weeks of relentless jungle operations in early 1944. The metal surface had developed unsightly rust spots, while the stock had darkened considerably from the combined effects of moisture and extensive handling. Furthermore, the barrel had become heavily fouled from the firing of hundreds of rounds without proper cleaning. Yet, when Carfree's unit engaged the Japanese positions at the Nakodik Pass, the rifle performed flawlessly. Interestingly, the sergeant noted that some captured Japanese rifles, despite their superior cosmetic appearance, failed to function reliably due to the adverse impact of moisture on their titer actions, leading to feeding issues. The Arctic environment posed yet another challenge, as British and Canadian forces operating in Norway in 1940 and later allied. Soldiers stationed in Northern Europe during the harsh winter of 1944–45 endured bitterly cold temperatures that plummeted below 0 Fahrenheit. Lubricants congealed into a gel-like substance, and metal components contracted. Moisture instantly froze on contact. The German military's response was to use minimal lubrication and specialized cold weather oils, but these required specific supplies that were not always available to frontline forces. In contrast, the British solution was more straightforward. They removed all oil from the Lee-Enfield's action, allowing it to operate without lubrication even in extreme cold. Canadian troops fighting in the Scheldt estuary in November 1944 reported that their Lee-Enfield rifles continued to function reliably in the face of sleet and freezing rain, while German soldiers' weapons were rendered inoperable by the icy conditions. The Lee-Enfield's robust and simple design enabled it to keep operating without the need for lubricants. The Lee-Enfield's enduring legacy defies conventional notions about military technology. Entering British service in 1895 as the magazine Lee-Enfield, it evolved into the SMLE in 1907 and remained the standard infantry weapon for Britain and its Commonwealth allies throughout World War II. But the rifle's story did not conclude in 1945. India continued manufacturing Lee-Enfields until the 1980s. This resilient firearm saw action in conflicts ranging from Korea to the Falklands, with the Canadian Rangers in the Arctic still issuing the No. 4 MKY variant as late as 2015. A remarkable 120 years after the Lee-Enfield's initial adoption. Its longevity can be attributed in part to the bolt's design, which required less force to operate even as metal contracted in the cold, a crucial advantage when every movement demanded extra effort. The Enfield design's emergence marked a significant milestone in military bolt-action rifle history. Unlike other renowned models like the Mauser 98K or the American Springfield 1903, which were quickly phased out after World War II, the Lee-Enfield stood the test of time. This longevity was not merely a result of nostalgia or bureaucratic inertia, but rather a testament to the rifle's ability to meet the fundamental needs of infantry combat. The British engineers did not prioritize absolute accuracy or precision manufacturing. Instead, they focused on optimizing the rifle for the realities of sustained rapid fire and reliable performance under demanding conditions. This pragmatic approach, rather than chasing technical specifications, ensured the Lee-Enfield's enduring relevance and widespread adoption. The SMLE rifle's rugged design and user-friendly operation proved more valuable than the Mauser's engineering sophistication, as effectiveness in the field outweighed precision that most soldiers couldn't fully leverage. This philosophy has repeatedly resurfaced in modern military small arms development, as seen in the early troubles of the M16 rifle in Vietnam, which mirrored the Mauser's struggles with mud and sand. The solution involved relaxing tolerances and adding chrome lining, principles the SMLE had embraced since its introduction in 1907. Similarly, the AK-47's legendary reliability stems from its straightforward construction, a testament to the enduring lessons of the SMLE's practical design. The Lee-Enfield's generous clearances allowed it to operate effectively even when filled with dirt, much like its predecessor's performance in the trenches decades earlier. Contemporary military doctrine emphasizes rapid fire and close-range engagement over long-range precision marksmanship, reflecting the same philosophy that led Britain to prioritize the mad minute over 1,000-yard accuracy. This rifle story offers broader insights into military technology and procurement, as advanced engineering does not necessarily equate to battlefield superiority. While the Mauser was more sophisticated in its design, with features like controlled feed, dual front locking lugs, and superior metallurgy, such complexity can also create failure points. In contrast, the Lee-Enfield's success stemmed from its simplicity and forgiveness, with loose tolerances and a rear locking mechanism. The Lee-Enfield rifle's straightforward design and user-friendly operation made it a practical choice for a diverse range of soldiers, from seasoned professionals to hastily trained conscripts. Its uncomplicated mechanics and intuitive manual of arms allowed even non-expert personnel to maintain it effectively, a crucial factor in the realities of modern warfare. Across several variants, the British manufactured approximately 17 million Lee-Enfields between 1895 and the 1950s, a testament to the weapon's mass producibility. The manufacturing process relied on simpler tooling and less exacting machining compared to the Mauser, enabling faster factory setup, quicker worker training, and lower production costs. This accessibility and scalability proved invaluable during the periods of high demand and rapid mobilization that defined the era. The Second World War era witnessed a strategic shift where industrial capacity became the decisive factor in equipping armies with rifles. While Germany engineered exceptional firearms, they struggled to produce them in adequate quantities. In contrast, Britain's manufacturing prowess enabled the mass production of the SMLE rifle, not only arming its own forces but also supplying resistance movements and allied nations worldwide. Quantity trumped quality, as the Lee-Enfield demonstrated that age does not equate to obsolescence, and modernity does not necessarily guarantee superiority. What mattered most was understanding the realities of how soldiers fought, rather than relying on theoretical performance. Ultimately, the best weapon was not the one that won design accolades, but the one that remained in the hands of the troops, ready to defend their cause. The British infantryman's unwavering loyalty to his aging firearm was not mere obstinance, but rather a testament to its proven reliability. Soldiers entrusted their very lives to this weapon, knowing it would see them safely through even the direst of circumstances. While the German forces boasted more advanced small arms, the seasoned British, Tommy, recognized the value of his trusty, time-tested rifle, a tool that had consistently delivered when all else had faltered.